In this video, I'll show you how to solve the ALEKS problem called identifying precipitation, combustion, and acid-base reactions. So in this problem, you have 4 different reactions and you're asked to classify each one of these reactions. Notice here that it says check all that apply, meaning that for some of these reactions, you're going to be choosing more than one of these boxes. The title is a little bit confusing because it kind of implies that we're only going to be looking at these 3 different types of reactions when in fact there's 4 additional types of reactions listed. I've looked through quite a few versions of this problem and it is pretty common for one of these to be the correct answer. In addition to that, the explanation on ALEKS doesn't really say anything at all about these 4 different types of reactions, so I think that makes it a little bit of a tricky problem. I'm going to start by defining all 7 of these different types of reactions to help you be able to identify them. I think I'm going to start with a precipitation reaction. In a precipitation reaction, you're going to have 2 reactants that are both in the aqueous state. They're going to produce one product in the solid state and a second product in the aqueous state. Not necessarily in this particular order, but this is the characteristics, what you're looking for. Precipitation reactions are always also double displacement reactions. I am going to define double displacement separately. Not all double displacements are precipitation reactions, but it's something to keep in mind. A combustion reaction is a reaction where you have some substance, I'm just going to call it X. It's reacting with O2, it produces CO2, and it produces H2O. And to identify a combustion reaction, you're just really looking for the O2 reactant and the CO2 and H2O products. And then last but not least, an acid-base reaction. The easiest way to identify an acid-base reaction is it's going to be a couple of molecules. I'm just going to say A plus B for acid and base, produces water, and then it produces some other molecule as well. And so this, the production of water is the characteristic of an acid-base reaction that you're looking for, but make sure that it is not a combustion reaction. So the production of water without the formation of CO2, without O2 being one of your reactants, that's what makes it acid-base. And acid-base reactions are also going to be double displacement reactions, although again, not all double displacements are going to be acid-base. You got to be careful. Now, a combination reaction, we'll define that. This is where you start with 2 separate reactant molecules and you end with just one single product. Those are pretty easy to identify. A decomposition reaction is the reverse of that. You start with one reactant and it turns into 2 products. So again, that's also pretty easy to identify. The single replacement and double displacement reactions are, I think, the hardest ones to kind of sort of sketch out the way that I do for the others. In a single replacement reaction, you have a total of 2 products and 2 reactants, and a total typically of 3 different atoms reacting, although that's not always the case. But you're going to have one atom, not necessarily by itself. It could be 2 or 3 of that same atom, but you've got one type of atom reacting with another reactant. I'm just going to call it BC. And in this reaction, the A is going to swap with one of the components of the other reactant. So that's going to convert it into something that looks like this. A single thing replacing another single thing. Now this swap that I'm showing here, it could be between these 2 substances as well. It would make this worded a little differently, but this is the general idea for single replacement. And then for double replacement, which is very similar, that is AB plus CD. And in this, you again get a swap. We're going to say A swapping for C. And that gives you, I'm going to have to move this over a little bit. That's going to give you C, I got to think about this, CB plus AD. So you're just getting a swap. Here we're swapping A for C. In the previous one, we're swapping A for B. And like I said, these can be pretty difficult to tell apart. So let's take a look at the 4 reactions that I have and see if we can kind of figure out where they fit. And I need to get this little blue arrow out of the way for us to be able to see this first reaction. So this first reaction, we can see that we have one molecule, one type of molecule, being converted into two types. That is an example of a decomposition reaction. And there is a decomposition reaction is just decomposition. There's not going to be anything else that we check if we have a decomposition. Again, the only time you're going to check two boxes is if you have a precipitation, which is also double replacement, or if you have acid base, which is also double replacement. Second reaction, we have two reactants converting into one product. That is an example of a combination reaction. For our third reaction, notice that we have the formation of water. There is no CO2 being formed, so we're forming water, kind of like an acid-base reaction. Before we decide, yes, this is what we're making, we do want to make sure that we are not looking at a combustion reaction because they both have the formation of water in common. And since I don't have any other characteristics of combustion, that means that this is an acid-base reaction, and all acid-base reactions are also double replacement reactions. And then the one underneath it looks like, again, I have another formation of water without the formation of CO2, which means I have another acid-base, which is also another double replacement.